as you design things, you're not thinking about any of that. You're like, oh, it worked on the computer. They can make it in real life. And that's just not how it works. 1 hour of engineering time is equal to 10 hours of shop time. If you mess it up, that's 20 hours.
Most people think manufacturing's dirty, boring, or dying. They're dead wrong. This is Manufacturing Runs the World. We're here to fix the misconceptions, teaching the next generation how modern manufacturing really works and why it matters more than ever.
You go by Matt, right? Matthew?
Yeah. When I was a kid, apparently, I really was on the gotta call me Matthew, but it doesn't matter anymore.
Okay, cool. You just kind of gave me the background. You also just taught me that it's Reading Bakery, not Reading Bakery. So thank you for that. Could you describe what a typical day for you looks like?
I'm probably getting calls strictly from the shop, but most of the time I'm just up here kind of interacting with fellow engineers and designing.
That is interesting, though. Is there a common challenge that you run into?
Yeah, I mean, it varies based on application. So we do a lot of stainless steel sheet metal design work and just stainless steel in general because of the food grade measures that we have to take to, build all of our machinery up to codes for whatever it is. A lot of times it's a matter of balancing design complexity with sanitation. Sometimes, you can make something really simple, but it may not be the most sanitary. And then once you've done that and found the sanitary version of it, you have to then do the extra fun task of finding the line of safety. When we send stuff to Europe, we have to follow their CE standards, conform European, and that stuff is really strict, but it is hard to make things simple, sanitary, and safe all at the same time. It's more of like one step out from that, thinking about how do people interact with this stuff? Is it going to be something that's usable? Is it something that's going to keep people safe? And then combining all of that is really the challenge. So I'll spend probably a third of my design time if I'm making a conveyor or a new machine. And then the last 2/3 to half will be kind of really getting in the nitty gritty of like, do I need to block off this area? Do I need to have some sort of electronic smart lock to keep people out of this area, shut the machine down if they open it, things like that.
Is there a mistake you would run into early in your career that you have refined at this point of your career?
Oh my goodness, yes. When you're out of college, you think you know some things and you just don't. Again, it's why I said I really wanted to be somewhere where I had a machine shop, I had a sheet metal shop, I had a welding shop, we have an assembly area. Because as you design things, you're not thinking about any of that. You're like, oh, it worked on the computer. They can make it in real life.
Right.
And that's just not how it works. So I would say now it's the safety, combining all the sanitation stuff. Before it was, can you actually just make it? And you learn how to make things that the guys down in the shop will not be angry about, or will be able to like give you feedback on and be like, hey, but it's not something as someone who went to college for mechanical engineering. You go and you learn all your equations and you learn, stress and strain and everything, but you don't have the practical knowledge that you need to be an engineer. I think when you first start out, that was really the hard part of like, how to tell the guys in the shop that you know what you're doing when you really don't. And then being able to like own it when you don't and being like, okay, we'll make it better next time. And then actually doing that. That's what I found for myself coming straight out of college to here.
Yeah. So a lot of humble pie when you first arrived there.
Oh, yeah. And I'm not ashamed to say that it's good for you. I mean, it's just part of it. That's just how it is.
Yeah. And I got to think because of the proximity of the manufacturing floor that you guys are able to work through common problems a little quicker because that feedback loop is literally downstairs, right?
It's really good to have that. We have a 1-of-1 machine that I designed earlier this spring, and that's going to be going through the shop here soon. And so I know like it's in my calendar to go down and check in on certain things while that's going through, because there are some things I've never done before. Right. And there are certainly some things the shop has never done before. And so I know that I'm going to have to budget some time to make sure that things are going to go through smoothly. Most of the time, we don't have to worry about that. But when you do brand new stuff, we do all custom machinery, but it's the style of everything is fairly similar. This thing is wild. So I'm going to be down in the assembly area, probably getting my hands dirty with the guys who are building it to help them create the vision that I had. And there's going to be issues, and I know it,
Yeah.
but I don't know what they are yet. So we'll find out in a couple months. We are doing our best to minimize design time of projects.
Right.
So as an engineering group, we're working on something called CTO, which is configure to order. Essentially, that allows us to simplify machines into groups of parts, like parts that change a lot, parts that don't change, parts that probably stay the same all the time. And we do so many different kinds of machines. I mean, I can think of at least 3 dozen types of machines off the top of my head. We've seen some success with that, which is good. And that's just me. I'm in one of the 3 groups. There's our forming group, our combustion group, and our mixing group. And we all kind of handle different areas along the line of baking equipment. There's just so much.
Yeah.
So much custom stuff to try and prepackage to make it easy for especially new designers. You don't want, new guys to come in and be able to mess something up really badly, and then they have to sit here and work at it and fix it. And everybody wants a good starting point. So they're not spending 6-8 weeks on one machine. You want to spend 2 or 3 weeks on a machine. That's about the right amount of time for us. We largely manufacture all the sheet metal and all the stainless, solid to whatever it is. But for lots of other things, we have partners that are outside of the company. So we'll have vendors come in and they'll kind of show us all their new latest and greatest offerings. And then our senior guys will kind of get together, kind of mull over the positives, the negatives, make sure that it's something that we can easily implement while maintaining what we currently do, and then also improve functionality for the end user, as well as make life easier for maybe the guys in the middle who are doing the programming, who are hooking things up. A couple of weeks ago, we had our pneumatics people in here from Festo, and they were showing us all these new blocks that they had and how you can program all this stuff with just a touch of a button. It's all more compact now. So something that was the size of like this keyboard is now going to be the size of this remote control. And that's awesome, because now as a designer, all that real estate on the side of my machine can be used to put more important things. I don't have to worry about allocating this giant box to pneumatics controls. I can worry about using that space for something better. Like, the most important thing on a conveyor is making sure that the belt runs straight. So if I need to position some tracking features that we have to align the belt at the spot where I would, normally have this, but now I don't, that's better for the customer, and that's better for us.
There's just so many things for you to think about as an engineer.
Yeah, there are. It goes from, I need to know the capabilities of most of the machines in the shop, and then you can kind of go from the branding of it to a different big idea of like, is this handle big enough for somebody to hold? Like, just little stuff like that. Like, is it going to be effective where it is? We have a little dummy model of a guy that we throw into designs to see if things are kind of appropriately placed, just to give us an idea. And, sometimes you throw the model in and you think, oh, you'll never reach that. You'd have to be Shaquille O'Neal to get your arm over there to lift that lever. And it's why we don't just design and send it out. We have in-house, everybody checks each other's work. So the managers of all the groups get most of the designs from the younger guys and the guys who work under them. And we review everything. I make sure that we're all happy with it within the group, and then we send it out. So, you've got to have more than 1 or even 2 sets of eyes on things. You just make sure that everything is going to be, top notch when it gets released. And then the few things that remain, can usually be ironed out pretty easily once it hits the shop floor.
Thanks again for taking this meeting, by the way, because I feel like every time I do one of these, I learn something new about manufacturing. I probably learned more. It's been the most educational for me. I got to think that putting out this content has got to be educational to anyone listening, right? That's what kind of motivates me to keep doing these, because like I said, I learn something new every single time. Before we leave, is there any advice you have for upcoming engineers or designers looking to get into this type of field?
It's super important to have that practical component along with your education. So if you want to go for engineering, that's great. But while you're doing your training, wherever it is, find something that you really like that has some sort of practical component to it with design or manufacturing, and just get involved. You're going to learn by putting some time into it. It doesn't have to be a ton of time, but an hour or two a day or something like that. The phrase I always remember when I was doing my training is 1 hour of engineering time is equal to 10 hours of shop time. Right. And if you mess it up, that's then that they've lost, that 10 hours and they're going to have to redo it. So that's 20 hours. Mm-hmm. So, take the extra hour, make sure your stuff is right. It's going to save you time in the long run, and it's going to save them time, which is good for everybody.
Thanks again for your time. Get back to making some stuff.
All right. I appreciate it, Justin. Thank you so much.
Yep.